Hello, welcome to AT&T ThreatTraq for August 9th, 2016. This program provides network security highlights, discussion, and countermeasures for cyber threats. Today we're joined online by John Markley. Welcome, John.
Thank you for having me.
It's good to have you here, and look forward to the quiz a little later on in the program. You always have some nice, thoughtful things to stimulate our noggins, so to speak. And here we have Stan Nerlov. Welcome, Stan.
Thanks, Brian, for having me.
Glad to have you here. And John Hogeboom, welcome. Now, John,
made it back safely from Las Vegas, Stan and I.
That's right. So you were at Black Hat last week and DEF CON as well, is that right?
Yep.
And so give me a little rundown. What did you find really intriguing about it?
I'll let you go first.
Okay. Well, I kind of enjoyed it. I got to meet a lot of interesting people.
Yeah.
I went to a training session on car hacking, so I used it more like as a hobby, but I learned a great deal. Some interesting talks at Black Hat, and I really enjoyed DEF CON because we got to participate in a Capture the Flag competition.
Right.
John, me, and a few other guys on the team, and we had a lot of fun doing that.
All right, great. And I hear you really had a good start.
First day was pretty good, and then that's where we peaked.
Yeah.
We got stuck at the very last question. But,
so it's kind of the hare and the tortoise kind of thing going on, right?
Yes.
Well, I'm glad you had a good experience with that. Anything?
Yeah, there were a lot of good talks at Black Hat, some better than others. I was kind of paying more attention to some of the telephony ones because I've had kind of a focus in that lately.
Yeah.
So there's some really good discussions with that, and a lot of them are available already up on the Black Hat website where you can look at the presentations and some of the white papers. So
we're going to be talking about a couple of things here today from Black Hat.
Yeah.
Right? All right, very good. John, I noticed you're wearing your Murray pin.
I do have my Murray pin.
And, we have an internal awareness campaign at AT&T of Murray is basically the spokesperson for that. He's running for office as an office for security awareness.
Right.
And his campaign partner is Edna. And so, if you're interested in learning more about Murray and our internal awareness campaign, there's a website you can go to. It's talkster.att.com, and we'll show you the URL. You can go visit that. And I think it's a nice twist on making security awareness a little on the lighter side, more entertaining.
More accessible to people.
And more accessible for people. So, very cool thing. So, John, let's go to you first. And I guess we all know that you have to pay attention to the security of your website, but who would have thought you have to pay attention to the security of other people's websites?
Yeah, that's the interesting angle here. So, of course, like you said, you want to pay attention to your domains, make sure they don't expire and whatnot. But in a lot of these various content management systems like WordPress and Joomla, these other frameworks that you might run on your website to present your content, in some of those cases, you'll install themes or plugins from third-party developers. And oftentimes those third-party developer plugins or themes will call out or have references to their domains to pull in some content that might be there or to update themselves or whatnot. So
or to learn about what you're doing.
Yeah, I guess to know that you're using their plugin and whatnot. So what happened here is they actually walk through a pretty interesting one of these plugins called FlexiTalk that had a big problem with this. But what these bad actors are doing, they're finding these domains for some of these older plugins, maybe a year or two old, and the domain has expired. And then they go register that domain. The bad guy registers it. And then they basically, it's not really a hijacking so much as taking it over
sort
because
of squatter.
Yeah, squatting, right. They're squatting on these expired domains, and then any websites, like any of these WordPress websites or whatnot that are still using those themes and haven't updated themselves, visitors to those websites are going to indirectly get push ads from this, the ones that have been renewed by the bad guy. So they're really mostly using it for ad distribution and whatnot, but they could use it for other malicious purposes if they really want to, because sometimes they'll actually import JavaScript from these other things. So you could be, technically, you might be able to get some stuff running on the client browser indirectly through these other websites. So it's something to be aware of if you have these. And I know a lot of people, we talk about this often, that sometimes you set up a website and you just, as long as it's running, it's fine, but you don't really pay attention to updating a lot of these extra components that you might be adding into your website from a third party, and you really should.
Yeah, absolutely.
Because something like this could happen.
This kind of brings me back to our discussion maybe a few weeks ago where we were talking about keeping track of all the components that are a part of your build.
Right.
So that you can basically keep a tab on any patches that are involved in this. It's not just patches in this case. You need to kind of be paying attention to whether it's actually continuing to be maintained.
Right.
If that has gone away, then you need to make some adjustments. So this is a little bit of even more subtle than what we were talking about before. You know, is there a support site or something behind it that may have gone away? Perhaps paying attention to the traffic on your, I guess you wouldn't even see that. This is going to originate from the browser
you
side.
might not, right.
Yeah.
You might deliver some page, or your website might deliver a page to the client browser that has tags in there that wants it to go fetch something from somewhere else or whatnot.
So you might even have to do some kind of some independent testing to verify things are working right from a browser perspective.
Right.
Yeah. And I wonder too, John, if one of the concerns would be if you had a frame on your normal website that had an ad service, you know, that just swaps through different ads. You just know about the ad service, but they'll have to keep track of all these expired domains as well. So you might be showing up one of these malicious sites and not realize it.
Right.
Yep. Absolutely. So, okay. Well, I mean, and that's even trickier in the sense that what you're really looking for is not necessarily something that has stopped working. I mean, if you can catch that, but this is a case where it started working again, but under a different, assumed by a different organization or a different person or whatever.
Right.
Now, I guess by the same token, though, when you're using one of these open source things and it's making connections out, you really don't, there's not really an integrity check associated with who that's connecting to, right? So, you know, it's hard to say. So you're putting some faith into that open source software or that tool or whatever that you're using as well.
Right.
It's a pretty tricky environment. All right, so John, let's go to you, John Markley, and I guess this is around mobile apps. You're gonna have to explain it to me a little here.
Okay, so almost 10, 15 years ago, I can remember giving a speech at one of the legacy companies about malware that morphed, that actually changed form, you know, based upon, you know, time of day, whether you attacked it, you know, detected it, whatever. Of course, you know, we've seen all that efforts, you know, in today's world, you know, that as things have changed, that's pretty commonplace. What we're now starting to see, at least in the mobile world, is, and it's somewhat hypothetical, but I really do think we're going to see more and more of it, is that we have mobile app collusion where components may not be malicious in of themselves. So you may go out to a site and download, you know, an app, you know, off of even a normal, you know, quote unquote good app store, and it's fine. Mm-hmm. But it may detect because of certain other apps that you have already installed on the device, you know, or get later on. It may be able to detect because of inter-app communication. It may say, okay, you have app 1, and now you have app 2, and oh, here comes app 3 getting installed. Now that all three of these apps are on the same device, it could take pieces of code from each of those apps and actually make a new piece of malware to reside on the device. Mm-hmm. And this is not something I think that's, you know, altogether startling from a PC or a server perspective necessarily, but from a mobile side, it's fairly new, you know, concern. And you know, and it's not just the apps; it's the SDKs, it's the libraries that go into it. You know, it's when these app developers, you know, they take a lot of stuff, especially in the mobile world, as we get into more open source too, right? They take pieces from all these different places, and they start putting them all together into their app. And some of the malicious actors are now recognizing that I get detected if I have it in one app. But if I can break it apart in some fashion, I can maybe sneak it by all the antivirus, all the other checks that get done on the device.
Yeah, it's an interesting point, and I kind of wonder, would this also apply to the permissions that you grant those apps as well? So
Absolutely. That's one of the biggest things I think we see nowadays is you grant app XYZ, right? I'm using terms here, pretty generic, but you grant that app, access to your camera. Well, because of the inter-app, collusion, and that's the term that gets used in a lot of the papers nowadays, you're actually could be granting a third app or a secondary app access to that camera as well because of the way that the apps communicate between themselves.
Yep, absolutely. So, and you may grant another app that you install another set of permissions that seem logical for that app, and then when the two get put together, it becomes a combination that you didn't really anticipate, right? Yep. So,
and
go ahead.
I was going to say the devices are pretty sharp in that you can sometimes see this. I mean, it goes back to that. Be careful about installing from third-party app stores or granting permissions that you may not want to do, or that don't make logical sense. But it also is just, what is loaded on my device? If all of a sudden you go through your app list, and it may not even show on the main screens, it may be actually in the list, and you all of a sudden see an app you don't remember installing, that's a little tricky to, and maybe something that you may, throw up some red flags.
Yeah, absolutely. And I guess my last little piece of advice on this would be, just to keep in mind, there is no free lunch. That is, if you download an app, if it's really cheap or if it's free, there's something they're gaining from that. And so you really have to, look at the fine print and make a fundamental decision about, is this really what I need? Is this really what I want? And especially if you're not using apps. I know I have this experience. I'll download, install an app or something with the intent of using it, or maybe I end up use it for a couple of days, and then decide, this isn't really what I need, and it's best to get rid of it rather than just let it accumulate on one of those screen pages or something. So, all right, very good, John, and some good important advice as we go forward here. And so Stan, let's go to you here.
Okay.
And this is a really cool story, in my opinion. So you're going to have to try to pull the pieces apart for us here.
Yeah, I definitely like this story. It's actually from a Black Hat talk I went to, and
right?
Information is also published online. So this one needs to be unpacked a little bit, because I think when you first explain
it's a malware term.
Because when you first explain it, people just like, oh, what are you talking about, Stan? What are you talking about?
Yeah.
Well, this researcher, Alexei Bulazal, what he did is he discovered a way to, I guess, fingerprint AV vendors. So the idea is, malware could try to detect AV or which AV it's running, and then try to evade detection from the AV. So, what are some approaches today to figure out what the malware is? So there's static analysis techniques and dynamic analysis techniques, and the dynamic stuff is more like a sandbox. You run it, you instrument the sandbox in such a way that you could see what are all the different API calls. So what this guy wanted to do, Alexei, he wanted to figure out how the AV works, how the emulation engines inside AVs work. But the problem is, how do you instrument the AV itself? I guess you could reverse engineer it or try to figure out how it works, but that'd be too hard and too difficult. So he came up with this, what I thought was an ingenious, very clever approach. It's basically created a covert channel of extracting information, communicating from within the malware out through the AV. So the concept is, right, the AV cannot emulate every function or system call. It's going to behave differently from the way a normal system would do. And he found that actually, if you get a host name for a computer, Kaspersky will return one value, but it's always going to be hard-coded. AVG might return another one, that's going to be very hard-coded. And that kind of creates a fingerprint. If you see this computer name or a certain mutex, you know that that's what it is. But how do you get that mutex or computer name out of the AV? How do you extract that out?
Out of the emulator.
Out of the emulator.
Right,
so
because
we know
it doesn't make any network connections or anything.
Right. It doesn't make any network connections. So how do you do that? So what the approach they came up with is to basically, I guess, it's map out every letter of the alphabet, let's say, to a different malware family, and then, let's say they make a call to get the computer name, and the computer name has certain letters in it, and for every letter that's in the, let's say, the computer name, they'll drop a different type of malware that the AV will then detect,
Right.
and then they will reconstruct the word based on the detections that occurred. So let's say, you know, they might drop Zeus for the letter Z, the Alina Paz malware for the letter A, and something like that. So then they can reconstruct that. And when I saw this presentation, I was amazed. I mean, it's not instantaneous because, you know, you got to run it and you got to extract it a letter at a time. But he was able to do things like enumerate the file system that the antivirus presents to the malware. And there's some really sometimes funky names over there that they put in there. And it's funny because it's just a developer. They think they're being clever. They put like a silly name in there or something like that. And now all of that's kind of exposed. The analysis was great. The presentation was, to me, amazing. Encourage everybody to read the PDF. Really interesting research. But what I loved about it most was this covert channel he created, which I thought was so clever.
It's a good thing there's so many types of malware available, so that you'd have a variety of signatures to be able to trigger. I mean, I mean, it's really kind of a dark humor in that, but it's kind of an interesting approach to solving his problem.
Yes. And then a bad guy who's able to fingerprint all these things, they could essentially make their malware AV aware for all these different vendors.
And that is one thing that Alexei did discover, that, you know, some of these mutexes are already known by the bad guys. And so if you search those longer mutexes on Google, you'll find there's certain sandboxes behave differently, you know, and there's malware actually looking for those and things like that. So some of these are known already by the attackers. What I know is maybe I'll grab a few of those mutexes, put them on my computer just for that added layer of protection in case the malware wants to.
You're inoculating yourself by putting fake mutexes on your machine?
I think so. It's kind of inoculating myself, right?
Right.
All right, very good. That's an interesting story, to say the least. And you know, I think it's important that stories like this are made available. That is, to be able to understand perhaps some of the techniques that some of the malicious actors are already perhaps using, and you know, they're discovering these things somehow. So there must be something like this going on.
Yes.
So very important for awareness. All right, very good. John Hoagland, let's go back to you here for a moment. And this is, I guess this is, you know, a typical scenario that you want to try to avoid yourself, right?
Yeah, well, I guess in my previous story I was talking about when you're importing third-party stuff and your website gets compromised. This was just a case of kind of a larger website called FossHUB. They're like an open source software or free software distribution site. There's a couple of different ones. Softpedia, I think, is another one that's similar to that, where you can go get, you know, download some of these various executables for, you know, public or public domain software. So a hacking crew by the name of Peggle Crew was able to compromise their website. I guess they had a service open. They kind of described it a little bit, I guess, in their when they revealed it to the owners of the website, that there was a network service that was open, didn't have authentication, and via that they were able to kind of get deeper into their cluster of servers. What they did initially was they just kind of replaced I guess, proof of concept. They changed out Audacity and a classic shell installer, and they Trojanized it with a master boot record piece of malware that was embedded in there. So if you downloaded those from FossHUB, you would get infected. Once people were onto them, I guess, or they were kind of discovered, they actually replaced it for all of the executables up on the website. And then I guess the long story short of it is that this master boot record virus that they put on, or actually I don't know if it's so much of a virus as it's just malware, that it only changed the master boot record, so when you rebooted your computer, it would bring up a message saying, and it was kind of like a goofy message about, you know, you should be careful where you download and install software.
Just sort of a defacement, or
be glad that we didn't, you know, install something worse on your machine. Still, you have to repair your master boot record, right, to get your machine back up again.
That's right.
Which a lot of people probably, you know, I'm sure there's a lot of people who would not know how to do that.
Well, it can be tricky to do if you don't have something to restore from.
Right. But you should be able to.
So they're hacking your computer to teach you a lesson.
Yeah.
Right.
Yeah.
So still not the right thing to do.
Mm-hmm.
It would be better if they just notified the owner of the website, hey, you've got this issue, you should clean it up, not go through this process of trying to make a name for yourself. But in any event, just another example of be careful. Make sure, we talk about on the show a lot, make sure you understand what services are open on your various network devices that you have connected to the internet, especially the internet-facing ones. Because if they don't need to be open, you should close them. Even the ones that are open, they should be restricted to only the people who need to use it. So like a website, you could open that for everybody, but the SSH, RDP, things like that, you would want to restrict those so that the entire internet cannot connect to them because they don't have a need to. And I'm not saying that's how this one was done, but some service was open there. They didn't say which one that they're able to leverage. So.
And the shame of it is you just provided some 25-year-old advice that's just as applicable today, perhaps even more applicable. It's become more critical in the cloud environment where, cloud services don't necessarily have a firewall in front of them to, by default, protect them. I mean, there are firewall services and things that you can put in front, but you have to actually do something about that. Whereas I think in some cases, people might take for granted that the network has some kind of a firewall protecting them. So it takes a little bit of extra effort to make sure that the system's locked down and that unnecessary services aren't exposed to the internet, especially ones that have vulnerabilities associated with them.
Right.
Yeah.
Yep.
So I guess the other thing that kind of comes to mind associated with this story is perhaps the value of a bug bounty program. That is, if you can provide some incentive to report the bug as opposed to doing some sort of defacement or some crazy thing like this, have a contact that they can report these things.
Right.
That's as readily available as you can make it. It may
prevent
motivate
you from having
folks like this to do the right thing and make it so that you can correct it without having to rebuild your systems.
Right.
Yep. All right. Very good. So John Markley, let's go to you and let's take a whack at this security quiz.
Okay. I swear the next comic book convention or whatever I go to, I'm going to have to get myself a wizard hat. I'm going to have to do it. Yeah, I wonder if I can voucher that off. We'll have to check with them all.
We'll let you voucher a tin hat, but I don't know about.
Yeah, there you go. So anyway, here's a few questions. These are a little different than what I've done in the past. So we're going to take a stab at a different thought here, and this is more of an intent to generate some conversation. The first question here is about the past. So the younger people in the audience may have some trouble with this one, but an early mechanism used for secure network transmission was A, Berkeley sockets, B, secure network programming, or SNP, C, Archie, or D, Gopher.
Yeah, I've got a feeling this is going to be an easy one for John.
I don't know if it is or not. I would say so my answer, so first of all, I don't think Archie or Gopher had any type of encryption in them I recall.
They're reverse search tools, aren't they?
Yeah, like Archie was like some kind of library indexing thing or something, and Gopher, I think, was similar to that.
Yeah, it was basically.
And then Berkeley sockets is just a network connection thing. It's not necessarily encryption. So I don't know what secure network programming is, so I'm going to go with B because that's the only one I don't know.
There's something about that name that suggests that perhaps it was used for secure network activities. So I don't know. Do you have any rebuttals here, Stan?
I actually am not familiar with many of these. Gopher, I've heard about in a textbook.
I actually used Gopher probably in the 90s, or late 80s, early 90s, but I don't even remember what it was like.
And I think I heard about Berkeley sockets. That secure network programming just looks so official, like it could really technically be something.
It has an acronym.
It has an acronym. Yeah. It looks like it's either a trick that John came up with here to trick us into picking that one, or it was something that was attempted. So I'm gonna, now that John picked it, I'm gonna have to go with that as well.
Go with me as well. Okay, John Markley, give us the scoop here.
Well, first off, you've all made me feel very, very old. Let's just say that up front. because I've used Archie and Gopher and Berkeley sockets. I can't say that I've necessarily used SNP. I've got to watch the acronym there. That is the right answer. But SNP was actually a precursor to SSL, and it actually uses Berkeley sockets.
Right.
So it's a direct connection. So it's a somewhat of a trick question in that it is a growth out of Berkeley sockets, but it is the protocol that preceded SSL.
All right, very good.
Okay, we're batting 1,000.
You're batting 1,000
so far.
I think you'll keep that up. So let's give you the present. All modern phones use what type of encryption? Maybe a little tougher one. A, DES, B, triple DES, C, AES, or D, blowfish.
Okay. Now, I'm guessing here you're not referring to the type of modern phones that have a dial on it.
No.
So you're referring to
mobile.
You're referring to mobile
phone.
devices. Okay. Okay.
Yes, exactly.
So
mobile phones.
All right. I'm going to take a whack at this one if it's okay.
Okay.
You know, I think if I remember correctly, blowfish was actually an algorithm that was created by Bruce Schneier. Does that sound correct? Yeah. That was considered a candidate, I think, when they were selecting between AES and there were perhaps some other candidates, but I think that was one of the candidates at the time.
Mid-90s invention, I would say, right? I think blowfish was around the mid to late 90s.
I think it was, it may have been invented around that time, and I think the evaluation was perhaps in the late 90s, early 2000 timeframe. I think it was after I'd moved to New Jersey 17 years ago, something like that. So I just remember. Anyway, DES is quite old.
Yes, older than most of us probably.
Right, and AES was designed to actually replace that because DES had that was the data encryption standard that was, sort of actually as the National Standards Bureau at the time when they had established that. And then 3DES was kind of a, if you do it once, maybe if you do it three times, it'll be better. So, it lengthens the key. But I'm going to have to go with the modern standard for encryption C.
I'm going to agree with you.
I would agree with you. I'm only worried that somewhere in the bowels of the old code, the DES lives on.
It is still in use. There are uses for it, and it's I think even a valid choice in some of the standard encryption solutions. But I think, based on sort of the recency of the current, like LTE standard, 4G standard, I'm thinking they're going to go with the most current. And plus, I think the computational complexity or expense around 3DS, for example, is, I think, quite a bit more. One of the things that they were looking for was efficiency. And actually, now that I'm thinking about this, I think one of the benefits was blowfish actually was perhaps more efficient computational-wise. That makes me doubt myself for just a little bit here, because one of the really important things about having a good mobile device is to be very efficient with how you use the battery. But I'm going to stick with AES here.
All right, I'm going to lock that in too then.
Okay, John?
Yeah, I'm going to stick with C.
What do you say, John Markley?
Again, you guys made me feel old with the DES comment, and older than most of us, because that was the 70s, and I remember the 70s.
Yeah, that was the 70s, absolutely. Yep.
But it is CAES. AES used to be a challenge in the mobile environment because there was a concern that the computation on the handsets couldn't handle it. Mm-hmm. But I think, Brian, as you said, modern technology is such that it does handle it fine. So they quickly jumped from DES actually all the way up to AES real quick in the last few years.
All right, very good.
So 2 for 2. And I suspect 3 for 3. Anyway, so let's go to the future. So here's some future, and there's maybe some argumentative statements that can be made that these future things are already here. But let's just kind of talk about it in terms of widespread.
Okay.
Some future security measures may include A, IPv6, B, DNSSEC, C, DMARC. I can explain what DMARC is if anybody needs to know, or D, all of the above.
All right. Stan, I think you get the drive on this one. You could, by the process of elimination, but we'll help you along if you like.
Well, I guess we can use IPv6 to secure against maybe some of the scanning attacks.
That's a good point.
You'll be hidden
Right,
in the
security
number
through
of
obscurity,
IP.
right?
Right.
Or just by the
Just
massive search space that
it's
you can't be scanned.
massive address search space. It makes it much more difficult to do an exhaustive scan of address
Right.
space. You have to have something to focus in on.
At least for the moment.
Yes.
Maybe 15 years from now, we'll be like, boy, that IPv6 space is small. We're running out of space.
Well, with all the IoT devices that are planned, maybe we will.
Aren't there more addresses than there are like
Grains of sand.
grains of atoms in the universe or something like that? It's some crazy.
I think
number
we'll
like
find
that.
out. I think we'll find out. Once we've addressed every grain of sand, we'll find out. The DNSSEC, it's got sec in the name, and it's I think it's used for authenticating the domains and signing the domains. So that could be a security measure.
It can also create some other security issues.
Yes, yes.
Like DNS amplification.
Correct.
Anyway.
And the DMARC, I'm actually not familiar with what DMARC is or what it provides, but because A and B is there, and they could both technically be used for security, I would say all of the above here. But I don't know.
I don't know what DMARC is either, so I would actually like to know what that is, but I'm sure John will be able to tell us.
Yeah, I'm not going to talk about it because I did cheat. I looked that up prior because I did not know what it was. So, but that's the only place where I cheated on this. And nevertheless, I guess the one thing I would point out, Stan, is in IPv6, the header authentication is required. So that's one of the things that prevents packets from being modified in transit. It's supposed to be one of the required features. And then I think the payload encryption aspect of it. So it's basically IPsec is embedded into IPv6 as a feature, but I think the encryption portion of it is optional. At least that's the way it is in theory. I don't know how much that's used in actual practice.
Yeah,
or how many.
I've never seen
how many devices are
automatically
actually
encrypted just by
well,
IPv6.
Even if you put the signature on there, the fact that doesn't mean it's being validated by the devices that are receiving the packets or transiting the packets. So that's one of the things that you kind of have to pay attention to. But it is a feature that's fundamentally built into the IPv6 specification, whereas IPsec was a tack on to IPv4. DNSSEC, to your point, John, it does have its trade-offs. I think one of the hazards in any security protocol is if everybody has to do it for it to work, it's probably not going to work because there will always be someone that is motivated not to participate in the security solution to basically thwart it for the rest of the criminals aren't going to want to do that. There are organizations, higher order that aren't going to want to do that. So it's going to be a very difficult row to hoe to make that a security measure in the future more broadly, unless some kind of an internet police is created that basically says, okay, if you're not doing this, we're kicking you off the network. And there really isn't a mechanism to do that today. So. And then I'll let John talk a little bit about DMARC here and see if we got the answer right.
So all of the above is your answer, right, Stan?
That was my answer.
I think you're right.
I agree.
That's how I got through high school, is just guessing.
It's always D if you're ever in doubt, right? Answer D.
Yeah.
So you guys have got it right. IPv6, as Brian said, has a number of security features. Some of those are optional that do enhance security, so it does have it built into the spec. DNSSEC, again, it's a may include, right? That's how the statement was, the question was asked. I think there's a lot of discussion still there. DMARC is kind of an interesting thing. If you're not familiar with it, and I always have to look, that's why I'm looking over here, it's domain-based message authentication, reporting, and conformance. Okay, so it doesn't, my brain's old. We've already established that in this quiz earlier on. I can't remember all those acronyms really well. Right. But essentially what it does is it enables you to do is that when you're transferring email from one server to another, from one, I guess, whatever you want to call it, it does a check to make sure that that's an authorized sender and an authorized recipient. So you actually get an additional security to reduce spam, because you can't just blast email. If DMARC is enabled, you can't blast email to everybody in your address book. It won't work. because the servers have to accept it and have to know who you are, and also have to be validating the recipient and the sender.
Mm-hmm. Yep.
So it's a really neat philosophy. It's been around actually for some time, but I personally think we're gonna start seeing more and more of that as we look into how can we defeat the spam, the spammers of the world.
Yeah, certainly. Well, and it's beyond spam. Spam is an annoyance, but I think the phishing campaigns, most often those phishing activities come from what purports itself to be somebody you'd expect to get a message from, but is actually an attacker, and that's one of the things that tends to mislead people into trusting the message. And it's a very important aspect of perhaps of improving the notion around email security. I guess, I mean, just the way you described this, I didn't go into a lot of detail investigating this, but I think it suffers perhaps that same constraint. That is, you need to be in a position where you're willing to reject anybody that's not conforming to that. That's going to be a very difficult threshold to overcome. It's one of the fundamental challenges in implementing security on the internet, is that if you have to make a decision about whether you're going to accept that message or not accept that message, because whoever's sending it is not conformant, then it's very tough to get there. At least in this case, perhaps you have an option to say, label the email not authenticated.
Right. So maybe when you're reading it, you could see, hey, this one did not, pass that extra level of validation or whatever.
So, I mean, there's a training aspect around that, just like there are for, TLS or SSL protected websites. If you don't see a green banner on the top, then you should be paying close attention. So this one at least has some potential promise, in my opinion.
Well, and then you also have things like secure BGP, like where you can refuse an AES because it's not passes. I mean, that's another one. Like you said, Brian, is if you start denying somebody access to share, a network, just the network itself, and that you knowledge of that network existing, that's a big block you can put in place either as a pro or a con.
Yep, absolutely. So I'm sure that we could have hours and hours of debate on each one of these. I thought that was a very good question, John, and I appreciate you bringing the quiz to us. Always entertaining and stimulating, educational. So let's take a quick look at the Internet Weather Report for the last week or so here, and looking at activity from August 8th here. We have lots of activity on port 23 TCP, surprise, surprise, and actually more than 50% of the probes are associated with port 23. Now, a couple of weeks ago, John, did you host last week?
No,
oh, you didn't.
I was gone last week.
You were gone last week. That's right.
Yeah.
So perhaps
no
it was
last
many.
week.
Nevertheless, I suspect that this was very similar to last week. 2 weeks ago reported a really huge amount of activity, probing activity on port 53413. We're going to take a closer look at that. It's still in here. It went down one step in terms of rank, but went down significantly in terms of the relative volume of activity. So we're going to like I said, take a little closer look at that. Followed by port 80 TCP. That went up 3 spots, but I took a look at it. There isn't really any unusual activity there relative to what we'd expect to see. Followed by port 22 TCP. It seems to be pretty much always on the charts here, looking for basically exposed SSH sites that perhaps will have weak passwords. Followed by 53 UDP, and I'm going to skip one and go to 123 UDP. These are perhaps probing around looking for sites that could be used for amplification attacks. Oh, we just talked about that a little bit earlier. Perhaps looking for sites that are serving up DNSSEC signed domains. And then 443 TCP is in between there, followed by 3389 TCP remote desktop protocol, 1911 TCP, and I have a mental block, but that's basically researchers that are doing probing activity for
Niagara Tritium Fox.
There we go, Niagara Tritium Fox, which is basically an industrial control protocol.
Like building automation.
And then 445 TCP with about a little less than 25% of that covered in the other category. If I remember correctly, it was on the order of about 21,000 other ports that are included in that other category. So a very broad sweep of ports that had been getting probed there. That's higher than usual. In terms of the top 10 most sources doing the probing, oh my. Port 23 is really big here. It's got more than 75%, closer to 80% of the number of sources that are taking place. That's more than 979,000 unique sources through the course of the day yesterday on August 8th. And then followed by 445 TCP, standard stuff, 53.413 UDP. We see 80 TCP in there, 6881 is actually PDP. And then there's 4028 TCP, and it's eluding me at the moment what that is, but I think it's.
I don't know. For some reason I want to say asterisk, but it's not asterisk. It's something else. I feel like it's another P2P.
I was thinking it is another PDP thing, so I'll have to take that as a homework assignment to verify what that is. Nevertheless, let's take a closer look at port 23 TCP, and on the top graph, the number of probes. On the bottom graph, the number of sources doing that probing. This is only 90 days of activity, so if you look at the bottom left side there, we have gone really up basically 2 orders of magnitude. Is that right? Or is it an order of magnitude in terms of the amount of activity that's taking place there in probing? It's what's 1 order of magnitude increase conservatively, and then almost 1 order of magnitude in terms of the number of sources that are taking place. Again, this scale is a different one. We're looking at the bottom, and it's showing, let's see.
But you went from like 50,000, maybe 100,000.
Yeah.
To 400,000 is the latest.
Yeah, 400,000, actually 400 plus thousand is close to 500,000 sources per hour in the activity in the graph below, and it keeps climbing. So this is basically that IoT devices that expose port 23 to the internet have default passwords. They're not well documented. People don't realize it. They don't think of these devices as computers, and they consequently get compromised. Predominantly used in denial of service attacks. A lot of this is that Lizard Squad,
right? They have a
stressor malware that has basically gotten into the public domain and is used by perhaps a number of different organizations. But it looks like this is really just a relatively large botnet under a handful of organizations' control here. In terms of scam probes and sources on port 53.413 UDP, you can see this has dropped off significantly. This was through the roof in terms of the amount of probing activity that's taking place. And it's very inexpensive computationally to be able to do this probing because they're just spraying packets out there. They're not waiting for any response. They don't have to do any TCP connection. And perhaps the device will get infected and actually connect into the command and control, but that's independent of this, the addresses that are involved here. And in terms of the number of sources, that's gone down as well. So there's a possibility some sort of activity was taken against this, or the other possibilities they were just successful enough with their recruiting that they are able to kind of lay low now and use those devices for whatever nefarious purposes they had intended.
And the SANS Internet Storm Center, just as an aside, they did a little write-up in their diary blog that they do as well about this activity. And some of the, I mean, we've talked about it before, what some of these packets look like and what they're telling the infected devices to go fetch and install on themselves. So,
yeah, thanks for bringing it up, John. And the SANS Internet Storm Center is a good resource for looking at things like this. And certainly if you feel that we should be reporting on something that we haven't, perhaps it's on the SANS Storm Center or you haven't found it there either, let us know. We'll take a look and see if we can, help out with some information about it. Next one here, scam probes on port 1720, that's H323, as well as port 5060 TCP. Usually you expect this 5060 is associated with SIP.
Yep.
Typically SIP is UDP. Typically. Right? Yeah, but
it doesn't have to be.
But it is valid on TCP as well, so there may be applications that are using it that way. The significance here is that just starting around the beginning of August here, and then continuing as we speak, we've seen an increase in the amount of probing activity. There's always some probing activity on these ports. Sometimes fraudsters are, probing around trying to find, paths where they can do, perhaps compromise a VoIP gateway and use that to perform, fraudulent calling activity. In this particular case, and this is specifically on port 1720 TCP, most of the probes, I think the vast majority, were associated with a single address in Lithuania. Lithuania. And so, nevertheless, that same address was also seen scanning on SIP ports, 5060 UDP, and a number of others around that. But the majority of those probes are actually associated with another address. And so there's a combination of activities that are taking place here. And like I said, if you, in particular, I guess the message behind this, if you have WIP gateways associated with your business, be cognizant of what those are, and also be cognizant of any scanning activity. Stan, you'd investigated SIP vicious activities in the past, but basically it's a password guessing kind of application that targets SIP gateways. This activity is out there. And then last but not least here, looking at the daily reconnaissance index over the last year or so here. I reported on this a couple of weeks ago, but wanted to basically give an update. All of this scanning activity that's taken place has really caused a ramp up over the last, we're going to say 6 months or so, relatively speaking. Actually about 3 months or so in terms of the ramping up that's been taking place. And that's relative, this is all measured relative to the amount of activity that's on the network. So it's all been normalized and still growing significantly, relatively speaking. So that's our show for today. We'd like to thank you for joining us. And if you'd like to get in touch with us, you can email us at attthreattrack@list.att.com. Again, if there are things that you've noticed that you think we should look into further, or if you have topics that you'd like to hear us talk about, we're happy to do that. Just get in touch with us. You can find AT&T ThreatTraq on the AT&T Tech channel. It's on YouTube, as well as an audio podcast on iTunes. And you can follow us on Twitter. Our handle is @ATT Business. I'd like to thank you, John Markley, for joining us today. Thanks for the quiz.
Thank you.
Thank you, John Hogeboom.
Yep.
Go Murray.
Go Murray.
And thank you, Stan.
Thank you, Brian.
I'm Brian Rixrode. We'll be back next week with a new episode. And until then, keep your network safe.